Hello everyone. In this video I'm going to create this amazingly complex and complicated game, the snake game. Okay, let me demonstrate you. Okay, so by swiping up using swipe, you can move in all four directions. The snake can consume the food and it will keep track of the score, and using double tap you can reset the game here. And if we put into more background and restart, the user will be able to start the game using a single tap. So that is how the project will look like when we are done with this video. Okay, so the goal here is to actually learn about Jetpack Compose by creating something fun. Okay, so let's get started. Okay, and in here I have just created a new empty activity project, and this is just auto-generated code, so I'm just going to remove this. Okay, so the first step here, I have to use create a surface and make use of this inner padding. Okay, now I'm just going to create a composable called snake screen. That is not what I want, but let's create a snake screen composable. Now the entire game is drawn on canvas, so I want to make use of the canvas available. Canvas here. I want to make use of the entire space available on the screen, so fill max size. The first thing I want to do here is draw text on the screen that shows what's the width and height of the canvas, and that we can access using size variable, width, size width. So now we have width and height information of the canvas. To draw text, we need, let's see, what do we need to draw text? So I'm going to make use of this one. Text measure is what we need, text and top left. So we need text measure. So text measure is just responsible for measuring the text in its entirety, so it is ready to be drawn on the canvas when we render the text. So let me just pass the text measure. Text measure. The next step is to have a pass the text. I'm just going to show width and height of the canvas. Right. And we need top left. Just going to pass like 100 points, like 100 by 100. Let's just go ahead and run this. So yes, it shows the width and height. If I just want to style a little bit, I can just say to have the font weight bold, and size is going to be 20 SP, should be good enough. So let's go ahead and run this. Okay, so before I start, let me give you some little basics of the canvas, and it's not as much. So in here, so this is the x coordinate and this is the y coordinate, and this is top left corner, it's point called 0 0. So we have width available, so x coordinate goes as far as 1440, and y coordinate, which is height, it goes as far as 62621. Okay, and this point is called origin point. Okay, so that's all we need to know about the canvas, because once you understand that, I think it's pretty basic. And in here we pass the top left, I guess. So this top left, it's 100 by 100. So from the origin point, I am calculating 100 x direction and 100 on y direction, and just placing the text there. So that's about it. The next step is to actually draw the grid on the screen. So let's do that. Okay, so I'm just going to keep the text to you in this grid. I want to have one grid 90 by 90 pixels, so we can define that cell as a 90 pixel. Now we have entire width and height available, which we can make use of that to draw the grid. 0 to width and step 90, or like we pass some. So when we are dealing with width, we are actually drawing columns, right? So when we are doing columns, we start with so let's just draw a line, and line requires for us to pass, hope you can see it, yes. So line requires a starting point, like first of all I have to pass color. Okay, starting point. So starting point here is width, means we are moving towards x coordinate, so I can just pass and 0f. We are not moving in y coordinate, yes, and would be offset. Here I will pass 2. So the same, it's going to be towards the down, but here I'm going to have to pass the height. So that's how it goes from 0 to height every 90 by 90 columns, right? And now I can just copy this. Here I'm going to deal with height, so this will draw rows, and when we are drawing rows, we are moving from x to 0f to here we are passing width, and in here I'm just going to use our y direction every 90 steps. Let's go ahead and run this. So this should show our grid. So yes, now we have a beautiful grid. So that's really cool. Now the next step here is to actually let me start by saying, what is a snake here? Snake is just on a 2D canvas. We can define snake as a series of rectangles attached together, right? So we can do this. So let's just do this here. So series of rectangle square attached together. So let's just do exactly that. So I will just say draw round rectangle. Okay, so each round rectangle requires for me to pass the color first. Just going to pass the red color. Each round rectangle requires top left, so where its position is going to be. So here I want to pass fourth cell on the x coordinate and fifth cell on the y. And yes, and it's complaining because we have to do floating points. Is there anything else we need? I think we need size here. So size is now, right now the coordinate system is 1 pixel, but we want to have 90 by 90 square, right? So I'm just going to pass cell is it complaining about? Oh dude, I don't want to create a new one, I just want to import it. Okay, so now let's go ahead and do that. So we have one square exactly on fifth and fourth, 0 1 2 3 4, yeah. So series of square boxes attached together. So let's just go ahead and create 2 more. Okay, I'm just going to say 4 5 4 6 and 4 7, and so there it is. So this can be called snake. So if we want to represent that data on the canvas, this is how we can do it, right? So simply, if we want to call this a snake, we can call it, right? Now every time we want to define a snake, we have to actually multiply by cell, and that can get tedious, right? And to solve that problem, we are going to use scale function. So it's a canvas transformation function, so it will transform the canvas and it will do exactly what we are trying to do here. So here what we want to do here is that every cell must be 90 by 90 pixel. So here we can define that. So I can scale x cell and scale y cell, and pivot point is from the origin point. We want to scale the canvas. So I think so now this is exactly what it says it is, that scale the canvas 90 by 90 pixel. So we no longer have to do this kind of multiplying cell. So this makes our life easier. So we can place this same code in this scale, and now we don't have to do this one. So we can remove this cell. We can remove this. So now we are working with normalized coordinate system. So when we say fourth cell, it is automatically calculating 90 by 90, and that's how this scale function will make our life so much easier, right? So now each cell size is not actually 90 by 90, is just 1. Now it's like defining 90 by 90 pixel square as 1 now. So this is why scale is so much important and like really useful when we are dealing with canvas here. So I don't want to keep this code here anymore, and I want to actually call this a scale factor because that's what it is. So just going to pass scale factor as a float here. So whenever we are creating this composable, we can pass it, but I'm going to give default value as 90, so I can just use that scale factor. Okay, Now this to represent the snake, what we can do is let's say we can just say value snake is equal to list of offset. Okay, so list of offset, so we can encode this data in a list, right? So empty list of, let's say list of offset. Okay, and I'm just going to paste this. As you can see, so this can be now on the canvas. If we define this, this can be represented as snake. That's the idea here. So I no longer have to do this one. I can just say in snake, I can just say this one. Okay. You can just say I.x and I.y. Okay, we no longer need this. And we run this. So there we have it. We have a snake, right? So that's the basic idea here. So we are going to use this data structure to represent the snake. Okay, before I do that, I want to actually calculate how many rows and columns will there be, and that we can do using this scale factor. So value, how many columns would there be? So whenever we are dealing with columns, we are actually dealing with width, right? So width divided by scale factor, I want to convert into int, and -1 because it starts from 0, right? Value rows, height, scale factor, -1. So now we have rows and columns available. Now let's set up the entire structure of the app. So I'm going to create a class called Snake Manager. Snake Manager. Okay. So class Snake Manager here. So now I'm just going to do the exactly same thing because that's what we need to represent that data, right? So initially, instead of having this, I want to have empty list, an empty list of what? Offset. So this will hold the position and body segments of the snake on the screen. Now we need to define direction as well, right? So I'm just going to use the enum class. So enum class direction, and just going to say left. So these are all the directions available. Here I can just say direction. Any random right now, it does not matter, because when we are initializing the snake, we will pick the random direction. Okay, so this is Snake Manager. That's about it for now in this class. Now what is the problem here? Okay, so I can just now create another view model which will hold the state of the UI for the composable. So snake view model. Okay, and extend view model. Now here I want to hold the state. So the snake can be in 3 possible states. At least that's how I've defined it, but depending on our preference we can have more states if we want. But to represent that state, I'm going to use seal class. Okay, seal class. I'm going to call snake state, and the subclasses are data class alive, so snake can be alive, and when it's alive I want to keep track of the body segments and its positions, right, which we can easily get using a list of offset, because that's what we are going to get from here, right? And we need to keep track of the direction as well, right? So direction, and we can create that, and we want to have one state which is initialized state. During that we don't need any information, and other state is that state. In that state I would just want to have the body segments, because when it's in a dead state I want to create some animation, right? So I need that information. Now to hold that state I'm going to use mutable state flow. So it's mutable state flow of snake's type snake state, and the initial state is dot init. So that is the initial state, and this is the private. To expose it in our composable, I'm just going to use state flow. State flow of type actually snake state. I'm just going to pass snake. Okay, there it is. Now here we also need an instance of snake manager, because that's where every bit of data about the snake's position, body segments, and what the current direction is, everything will come from that snake manager, right? So we need to have an instance of that. So I can just say snake manager, and we can just create the instance just like this, because it doesn't depend on anything. Okay, so now that we have this snake state, we can use this state to actually show it on the screen, right? For now we are just hooking up wires, like connecting everything together, so just bear with me. Okay, so let's use that snake state. Okay, and to do that I have to actually initialize the view model first. Okay, so of type snake model by to import this. So now we have that. I'm just going to pass it here. I need to update that signature. There it is, simple. And we can now utilize that state snake dot collect as state. This by is, it's weird because it never gives me that import that is necessary, so I'm just going to do it myself. Compose runtime. I think it's set value and get value. We want to have both. There it is. So now we have snake state available. So if we use this, when state is equal just mangling this one. Okay, so we don't need this anymore, so let's just comment it out. Add remaining branches. So this is one of the benefits of using seal classes. So you can definitely define these subclasses as an abstract class, snake state as an abstract class, and have this subclasses of abstract class, because under the hood seal classes are same abstract classes. The main benefit that Kotlin provides is that all the subclasses are known at compile time, and because of that, when is able to say these are all the possible states that are available during compile time, not runtime. So and that is one of the like appealing or like most useful feature of seal class, and that is why it is more preferred over abstract classes, because they provide this feature. So as a programmer, we don't accidentally miss handling certain case. So it's like checking the when expression exhaustively, right? So now we have these 3 states available, and here as we saw, like value, we can get this snake from state, and we can also get direction from here. Now in initialization stage, I want to initialize dummy data for now. Okay, so let me just say snake ViewModel init snake, that's what I'm going to call it, and I want to have it down. And as I said, the snake manager will handle every responsibility of where the snake is, so I'm just going to create that method in that. Okay. So here that is it, and I can just now make use of that dummy data that we already have, and that one. Okay, so we have all the data available. So I'm just passing that dummy data. Really, let's just call points, and I can just assign that point in here, and it's complaining because I need to update it to variable, so we can update. So now what is happening here is whenever this composable initially composes initial composition, it will go here and then render this state, okay, and initialize the snake. So we can just check. Let's go ahead and run. So nothing will happen at this point because we are not rendering that, right? So in initialization, we are initializing it, and now just for the sake of testing, let's say yes, so currently we do not have any data available or any state available like this. So temporarily I can just say update state. Just going to name it state, and I can just pass any state. And I can just update like this. So I want to pass it alive here, okay. And now newly generated these points, random dummy points, they will be available here. So I can just make use of snake manager dot snake, and position it has already like direction, sorry. So we have direction. So now on the snake screen we do have available this data, right? So which we can use it to just draw it on the screen, right? So for I in snake, around rectangle, I can just say color. Of course we need to pass the size, otherwise it will not make it. So let's go ahead and run this. This should actually show us exactly what we defined before, right? And yes, it does. Okay, so now we are making use of the state view model, holding it in the view model and updating it when it is initialized. Now I want to actually draw the grid first. So when we draw the like a background grid, okay, so and to draw that grid we have all the necessary information, which is columns and rows, right? So let's go ahead and do that. Function, I'm going to create a function. Draw grid. Okay, so it would require me to pass rows, columns, so it's just int, and this canvas, right? If we want to DrawScope. Okay, now that we have all this information, I in 0 to rows, and we need to take into consideration about these columns. The columns, and then the grid was like alternating colors, right? So I want to alternate using odd and even, so that is super easy. I can just say value v is equal to I plus j if v2 0, then I just want to draw round. So I need to do here canvas round rectangle color. So in terms of grid, I want to pass gray color and use the alpha value as 0. Let's say 2. Okay. Of course, we require it's 2 by 2. Okay. We require top left or certainly. Now we have columns, so when we are dealing with columns we need to pass I to float, and I think it's so yes, when we are dealing with the x coordinate we are dealing with the columns, right? So column is j to float, easy, my to float. That's all we need here. Certainly we need to pass size here. Now depending on odd and even number, I want to change the alpha value a little bit, right? So the grid would look nicer. It's just 2, 3, and oh yes, sorry, I need to actually call this function, right? So I can just say draw grid we can pass the rows, we can pass the columns, and we need to pass this. Let's go ahead and run this. It takes into effects a little bit slow, but yeah, we have a beautiful grid. It looks amazing. And so now that we have grid, I think there's one improvement that I would like to make here. It's like I have to pass this, and I don't have to do it if I use actually Kotlin, you know, function like extension functions, right? So extension functions, I just have to pass DrawScope dot this, and now I don't need this parameter, and I just have to, you know, delete this, and there it is. So that would just allow us to not pass this unnecessary canvas. It would just be available inside this function as this, right? So that's one of those useful feature of Kotlin, right? So it's fun. So now we have this grid and we have Snake available. So currently what we are doing here is initializing the Snake with the dummy data. So what we want to achieve here is randomized position of the Snake, right? And to do that, we have to select one random point on the screen. So let me just show you. I mean, I don't have to. So yeah. So in initialization of the screen Snake, I can just initialize. Yes. Okay. The main point here is to initialize it. Here I can do this. To select a random point on the screen like this, I want to be able to first, you know, just a minute. Yes, I need to know the width and height of this canvas if I really want to have a random point within those constraints, right? So we need to actually save that board, and to save that board, I mean we do have all that information available right here, right? How many rows and columns will that be? So all we had to do is just save this on board, right? And for that I'm actually also using going to use one flag, which is save board. And I need variable, just import this, and I can just say mutable state of true. Okay, and the reason for this flag is to prevent unnecessary execution of this method, because the amount of rows and columns will not change unless we rotate the screen, right? So we don't want to unnecessarily keep updating updating or executing this method unnecessarily, right? So let's go ahead and do that. Save board. So I'm going to be save board is equal to false, and now I can perform like save this in Snake Manager, so it has all the necessary information to generate a random point on the screen. So ViewModel, just going to call it save board. Manager. And yes, I forgot. So we need to actually pass offset. I can just convert into offset. So first is we need columns actually, because we are dealing with width. dot to float and rows to float. And we need to actually update this signature of type offset, and we can just paste it. Just going to create here, and I can keep track of it by saving it. Variable board is offset, and I'm going to initialize here with 0 0, but once this method is executed, I will have proper value of the available board here. And of course I need to actually change it to variable. Okay, so here I'm going to save the current board width and height, right? So now I have all the available data in Snake Manager to actually create a generate a random point within the rows and columns that we have available on the screen. So I can just generate it using variable x equal to random. So let's generate one point, okay, first, and then we can next in from 1 to board.x to int. Okay, so this will generate a random x point within that amount of columns available, and y is going to create choose a random point within those constraints, right? And so now we have one point available. We can create one, let's call it points, okay, and it's going to be a mutable list of, I want to create a mutable list. Okay, I want to create a mutable list because we want to add it, right? So now we have points, right? Why is it complaining? Okay, we are copying it. Okay, so we have these points available, and first point is automatically generated. And when we are initializing this snake, we also want to pick a random direction, right? So I can just say direction is equal to direction dot trace, and here just from 0 to 4. So in this one, whenever we are generating random int, so this last position is excluded, right? So we want to generate a random number from 0 to 3, 0, 1, 2, 3, and the fourth one is excluded, right? So based on that, we will have a random direction here, right? And now that we have that, what we can do, so the basic idea here is, let me explain by drawing. So we created one point, right? So randomly, let's say on the screen, this point is selected, and this randomly generated direction is, say, left, right? So if it's left, then we are considering this randomly generated point using xy a head, okay, head of the snake, because that's the first point. And we are going to generate a random snake because initially it can be on any position. So based on this direction, I can just append to snake like this, because it's going towards left direction, right? Because head is the first, so we need to pass it after it. So, and because if it's a left or right, then we are dealing with x coordinate, right? So if this position is let's say 5 5, then, and if it's left, then all we have to do is increment it, because x increments on this direction, right? And we are going towards this direction. So 5 5, 5 6, and 5 7 would make something like this, right? Now let's say if random generated point is here and the direction is right, then you're still dealing with x coordinate, but this direction is right, so, and this is head of the snake, so we have to do x minus minus because we are putting points here, right? So that is the basic idea here. Okay, so what I'm going to do here for I in, I want to create initially 1 2 2. So 1 point is already created, and now I'm just going to execute this loop twice and just create additional points based on the direction that I have available, that is random, right? And now I can just say, so if it's left direction, if I'm going this direction, then I have to do plus plus, right? So I want to do x plus plus. Okay, and first of all, in this point, this newly generated point, I want to save it, and yeah, we need to have offset, right? To float. Why not to float? Okay. Okay. Stop complaining. Okay, go. X plus plus. If it's going towards a right direction, like this, then you have to do x minus minus. Yes. If it's going up direction, then head of the snake point will be up, right? So you are going downwards in y coordinate, so I just want to do y plus plus, right? And when we are going down, it's just opposite, y minus minus. So that is the basic idea here, and every time you update this, I want to add that point, and I just need to copy paste out this, copy and paste. Okay, cool. And of course I need to assign that points, those points, assign those points to snake, so that way we have updated randomized snake position available for this view model to use, right? And here I can see that I'm not using this I, right? So I can just use this repeat. I think it's higher order function, so I just have to press 2. So just repeat this twice, and let's just go ahead and see. So this should give us a randomized snake every time we run, right? So okay, so yes, it is there. Now let's run again. Yes, as you can see, it's generating random position every time we run the application. Okay, so that is the idea here. So initially we generate the random location based on the available width and height of the board, right? So now I want to draw a snake properly, I think, because this is not how I showed you initially, right? So let's just draw this snake. So in a live state, now we have available all the data, right? So I can just create a method called drawSnake, and this will we need snake, of course. Is there anything else do we need? I don't think so. Let's just go ahead and do this. Okay, so of course I want to pass this draw this. Okay, and so we have all the offsets available. So for in, let me call this snake because it is snake, right? We are calling that snake indices, and I want to alternate the colors so we can do the same that we did like by modular, right? So that's why I used indices, right? So if I 0, then we want to draw different color, right? So draw round rectangle. I'm just gonna pass color. I want to start with green color, right? And let me see if I can do that. Then what we need to do is offset, by the way. Round rectangle requires me to pass the top left, right? And that requires offset of snake of I dot x, snake of I dot y, right? So that's all we need, and of course we need size 1f, right? So that's all we need for the snake. So let's go ahead and run this and see what happens. Oh, yes, I did not check this. Yes, I need to pass black color, right? Well, what is happening? So I'm passing this. Yes, because of doing that. Yes, I need to pass it actually else. Silly mistakes. Anyway, so yes, this is I'm drawing the snake now, and that's about it. So what's the next thing that we need to do? So we are already handling the state. We are randomly generated the snake point. I think what we need to do, the next step here is to you know what, let's go ahead and at this point we do not have any direction available. So let's go ahead and first of all start moving the snake. And what do we need to do in order to move the snake, right? I think that would be the appropriate next step, right? And in that case, I think we need to have a loop, right? So in composable, so composables are not like normal functions. They are different sort of, they are functions, but they are different functions. And the main idea here is that it holds the state, and here we have this state as well, right? Snake state. Now whenever this snake state is updated, the entire entire composable will recompose itself. It will go through recompositions, and that is what I want to do here. I want to have some sort of a game loop, and in that loop what I can say, every certain amount of time I want to refresh or redraw the entire screen, and by doing so it will look as if the snake is moving. So that is the basic idea here. So let me just go ahead and code so it will become more clear, I guess. So whenever we are initializing it, I can just call, like, create first of all a function called moveSnake. And moveSnake, as I said, it will be, so let me yeah, create a loop, right? So I can just say create loop like this, and depending on this, like snake value, I want to take certain actions, right? So that is the loop here. But if I do this one, what will happen is, like, this is an infinite loop. It will keep going, right? And this will actually cause the main thread to block UI operations, and it will create Android non-responsive, and it will crash the app. And that is not what we want. We want some sort of a way to make this operation non-blocking and delay this function for a certain amount of time. So that's what we can do using coroutines. So coroutines is exactly what we need here, is an idea that execution of a function can be suspended for a certain period of time and can be resumed later on. And it is non-blocking because it's asynchronous programming, right? So that's what we are going to do. And here we can launch a coroutine using coroutine, like ViewModelScope.launch. So I can just move this entire scope in here, and I can delay it for a certain amount of time, right? And I'm going to pass delay value. Default delay is 110, and I want to have variable called delay, which would be initially default delay. So I can just pass this delay here. Okay, so now it is, so basically what this is doing is just launching a coroutine that is tied to the lifecycle of ViewModelScope. And ViewModel survives configuration changes. So even if the view is destroyed, our ViewModel will survive that, and we will still have Snake's state available. So it will be tied to that scope. I think ViewModel only gets destroyed when activities finish method is executed. So before that, any other lifecycle methods are triggered, ViewModel will survive, right? So this is why like in ViewModel you should use ViewModelScope, and by launching, you're launching coroutine, and I'm not passing any dispatcher, and so it will automatically run this coroutine on main thread, non-blocking way, right? So here is the idea. So while true, so this loop will run infinitely, and I am going to say move snake, okay, like snake manager, but move snake. So I don't want to implement. So now I can say move snake, and I can say update snake state, and with updated new value, right? So I can just say snake state dot alive, and I can just pass snake manager dot snake and snake manager. So what I'm doing here basically is snake manager has all the points, right? What I will do in move snake, I will move all these points in a certain way. So if it's going towards the left direction, then I'm going to swap the position of the x and y coordinate towards the x coordinate, update that and save it as snake. And now I'm going to update here as alive and make use of the latest available position. And when I update this state, this state gets updated. We are collecting as a state, right? So I am passing at alive state, so this state gets updated. And this is why Jetpack Compose makes our life easier, right? So it is reactive. So whenever we change that state, this entire canvas will be redrawn. It means it goes through recompositions, right? And it will redraw with the new available position. And that's, by doing so, it will look as if the snake is moving. So that's the idea here, that infinite loop will keep updating the position of the snake, and Jetpack Compose, it will keep going through recomposition. So keep drawing snake again and again every 1.1 milliseconds, and that's how the snake will move. So the next step here is to actually code this method like moveSnake, right? So moving snake here, it should be really easy, right? So I want to first of all copy okay. Copy as a mutable list, actually to mutable list, because I want to update it, right? Maybe not as much, I think. So for I in list, for every element, when direction is, so that's the basic idea here. So in here, I can just get the value of x and y. Okay. Now if it's going towards the left direction, right? So I need to actually, so if it's going towards that direction, then I want to do x minus minus, right? If it's going towards right direction, then I want to do x plus plus. If it's going towards up direction, then I want to do y minus minus. And if it's going towards down direction, so downward, so it is incrementing it, right? So y plus plus. So that is the basic idea here, okay? And so every position I want to update it, right? So I will just create a value, another date is equal to mutable list of offset. Okay, I can just save it now, right? And I don't think I need to do this. So I'm updating all these coordinates, and now I can just save it. Okay, update dot add set x and y. Okay, so that's all there is to it. And now I can just say that snake is going to be updated now. Okay, so this should work. Okay, let me go ahead and run this. Okay, so it won't actually work because I'm not calling this moveSnake method, right? So in initial state, after updating alive, I can just say moveSnake here. Okay, So the entire flow here is that it will initial compose of this composable. It will go through initialization state, and in here we are going to create random points on the screen, and this will start the loop that will keep updating the position by calling this method, and then we are updating the state, and whenever we update the state recomposable, this canvas will redraw itself. So that is how it should work. So let's go ahead and run this. Okay, what is happening? We have empty screen. That should not be the case. Let's see. What is happening here? So yes, let me just yeah, so this is not working, and the reason why it's not working is it's unclear right now. But let's see on ViewModel. So I think yes, so I need to delay. Okay. So I need to delay it here, because right now the entire while loops keeps running and it's not delaying, right? So I think it's not doing anything, so we need to delay it here. Okay, makes sense. Okay, so yeah, now we can see the snake is moving, right? So if we run this, yes, okay, cool. So when we are running, so we can see the random snake position, and it moves just as we theorized. I mean, updating snake every time in the infinite loop, non-blocking way. Okay, now the problem here is that it is going out of the screen, right, outside the visible area of the screen, and to prevent that we need how many rows and columns are available, and we have all that information available in this board, right? So we can make use of that, right? So if it's going minus, at some point it will hit 0th position of the origin side, right? So let's say if x is less than or equal to 0, then we want to reset this position to the end of the width, like the entire, the last column, right? Because we want to make it visible to the other side when we reach the end of left side. And so we can do that by using board.x, and else just keep doing the same thing that I am doing, right? During right side, if I'm traveling right side, I hope I can just clarify a little bit. So if I'm going right side, then it will hit here, which is column size, right? So I want to reset it to here 0, and the same goes here. Whenever the y direction is, if it's hit 0, I want to reset it to board number of rows available, which is y, right? So hopefully that clears it up. Okay, so if I'm going right, then it will eventually hit x is equal to greater or equal to board.x, and then I want to reset it to 0, right? Otherwise keep doing the same thing, right? When we are the snake is moving towards up direction, then it will eventually hit 0, right? So if y is less than or equal to 0, Then what I want to do is reset this to board.y, and I'll keep doing the same thing, right? I will format this code. I want to do this. Okay, hopefully it's visible. Now when we are going down, eventually y will hit if it's greater or equal to board.y. Then I want to reset it to 0, else just do that, right? So that is the basic idea here. Let's go ahead and run this and see if it works. Okay, cool. So it does work. Okay, I want to see if it works in up and down direction as well, so I can see, like, not this one here. Okay, so it does work. Okay, cool. It does indeed work. Okay, so I think I want to test a little bit more, see if there's no any problem, right? Because we don't want to find it later on. Okay, I think it works. Okay, if there's an issue, we will figure out together. Now, next point here is actually, what's the next logical step is moveSnake, and now I think we should be able to control direction, right? If we were able to control direction, then we can actually, you know, see how it moves, right? So currently the infinite loops keeps going, and we are updating the state again and again, and the composable is recomposing itself, and that works as intended. To keep track of direction, I want to update direction based on the swipe gesture, right? And for that, I'm going to make use of pointer input. Okay, pointer input, and in pointer input I think use unit as a key, and there's a different, I think, detect drag gestures, so that's what I'm interested in. Let's see what is available, right? Let me hide this first. Okay, so let's see what's available here. It's drag. There's a this lambda function provides me with two options, which is pointer change and offset, right? So let's just say change, and offset is not something I'm interested in, so I'm just going to say that. And now what I want to do is, what I'm interested in is on drag start method, of course, and on drag end, because I want to know when the drag ended. Okay, and that's about it. So what this provides, like Q, if I say Q, I think, yes. So on drag start, it provides me with the offset information. On drag end, it does not provide me any information, but on drag, pointer input change. So what is on drag start? Let's say offset is provided. On drag end, we know when the drag ended, and change is what we call here, let's say let me explain you using this. So if I place like touch input here, start here, and if I keep dragging like this, then every drag points are registered here in change. So every drag point will be registered here. On a drag start, we already on drag start we will get this offset, starting offset. Like if I do like this swipe, so this will be available here on drag start. And on change, every change that is happening whenever we are dragging it like this, every input change is available. So this can be used to get the final position, which is like this. Let's say drag ended here or swipe ended here, then change will have the last point that is available, and by finding the difference between these two we can determine which direction we are dealing with, right? So let's go ahead and do that. I will actually make use of Locket, and I will show you all the information first. So I'm just going to say my name because why not? And in offset, what I want to do, just print the drag start idea, drag start. Just going to say offset. Okay, drag end, I don't have any information here, but I can just, you know, pass that information in drag end, and here I can just say change to position dot, yeah, just position, because it will give me the entire position available, right? So let's go ahead and run this. Okay, so I'm going to swipe using, let's say, yeah, you can see the data. So you can see that drag started at around 900. So let's visualize this one. So, you know, why not? I'm just going to turn off my camera for a second. So let's visualize this. Okay. So it started around x-axis. This is x and this is y. At x-axis it started around 900, so probably around here, and it ended at 0, 0. Wow. Okay, so we certainly went like this direction, but let's say this one started, y direction is 1300. So if it's the entire width is 200 and it's around here, so around like this happened, right? So we can see that absolute value between this and this is, the difference is around 100 coordinates, and between 900 and 0, so you have already almost 900 difference, and here is only around 100, right? So based on that, what we can know is that it traveled towards x direction more than y direction, and that's how we know we are either dealing with the left direction or right direction. If the swipe gesture was like this, let's just clear this, and if I do down, okay, mouse pointer like down, so we can see in here my x direction didn't move as much, the absolute value between these two, which is like a delta difference, but in y coordinate it started from around 600 to here to went to 700 around here. So based on this available information we can deduce the direction, and that's what I'm going to do here. Okay, so we have all the necessary information. So I'm going to keep track of swipe position using two variable start swipe position, remember, and I can just say variable state of and offset. I'm going to say start with 0, 0. Okay, both the positions and end swipe, right? And then here I can just say end swipe position, both are at 0, 0. So starting swipe position, we have easy way to get this using here. So I can just say start swipe position is equal to offset, right? Now end position, every change that happens we can keep saving it, right? So end swipe position is equal to change dot position. So now we have both the points available. So on drag and I can actually print out both of them. Okay, so we'll have a kind of like a final position, start and end, and here I can just make use of start swipe position, and here I can just say end swipe position. Let's go ahead and run this. And if I do like logcat, just a minute, if I do it like this, let's do again left. So yeah, starting position X is 1000 and it went in X direction 0 0, and from Y didn't have as much difference, so we know that it's going towards X direction. And then to find out whether it's left or right, it's even more easier, right? Because it started as greater X, so we know it's on the right side, and it ended as 0, so it went on the left side, right? So that's how we know. So if we do it like this, then it started as less X and ended as greater X, so it went towards the right direction. So that would be incredibly easy as well, right? So let's go ahead and do that. Okay, so I'm going to first of all value delta X. So delta X is the absolute difference between those two values. So I'm going to say swipe.x minus n swipe.x. Okay, I'm just going to copy y. I'm just going to say y. Okay, so now we have delta difference between the two. Okay, if dx is greater than dy, then we know this is horizontal. Swipe or drag, I don't know, in Jetpack Compose it's different, but we can just call it swipe. Okay, else vertical, right? Now here what I can say, if start position dot x is equal to greater than end swipe, then we know that we are dealing with left, right? So we can just update the direction based on that. So snake ViewModel update direction, I can just pass direction dot left, right? Because x is bigger than the ending position, so we are going towards left direction, right? And else I can say we are dealing with right direction. Right now we don't have that method available, but we will do it. Okay, same goes here. If start swipe position dot y is greater than end swipe position dot y, then we are dealing with up direction, right? Up. Else we are dealing with down direction. That's how simple that is. Okay, and let's just go ahead and create this method. Oh no, how to control this. Cool. So snake manager knows the current direction, so we want to update there, right? So direction update direction, right? And I'm just gonna pass the direction. Pass the direction. And here I can just say I just want to call it direction because I don't want to mismatch like the name. So direction is equal to this newly passed direction. Okay, so let's go ahead and do that. Okay, so now we have the ability to swipe and change the direction. I hope so. Let's see. So yeah, okay, so that is doing it, right? It's not entirely correctly but it is doing it, right? So we can go down and we can go up, right? Up and go down. So we need to fix this this problem that we have, and the way to fix this is what is happening in moveSnake, right? The way we are updating this position is like, if it's going down, then we are calculating it perfectly, right? If the direction is, it's like y plus plus, and when it hits here, I'm just going to 0, so that works fine. But when I do this one, so whatever the available points are, it goes towards this left, and all the points are doing minus minus, all the points, because we have this loop, right? And that's exactly the problem here. We don't want to do that. We want to update one point, and then other points we just want to rearrange the position, and that would actually accurately update the snake direction, right? So let's go ahead and do that. Okay, let me go ahead and do that, and then I can explain you a little bit better. Okay, so let me go ahead and do that. So I am copying that. So first of all, I want to get the first position of the list, which I'm going to call head. I want to pass it head list dot 0. Okay, now I have the first element, but I don't want to do that. I think there's another better way, I mean concise, I guess, more clear, I guess. List dot first. So this is equivalent of saying list of 0. Okay, now we have the first variable x is equal to head dot x, variable y is equal to head dot y. So we have these two variables available. Okay, and we don't want to update all the elements. Okay, we already just want to update this head, the head of the snake, because head of the snake will determine which direction you're going, right? So I just grab those two variables, and based on that, I'm just going to manipulate the head only one point, not the entire points, because before we had a for loop, and every point we were updating x or y or either direction, depending, like for all the points depending on the direction. But now I'm just saving that head position and only updating that one, and I remove the loop, right? So I think now it won't complain. So let me just, oh, I made a mistake but that's about it. So I'm updating, so this update is fine. Now what I need to do here is, I have the list available, right? So for I in 1 2 snake dot size, okay, of course I want to do less than that. I want to add that same update dot add. I'm going to pass the head. Okay, and the next step here is to update the head now. Update the head with this currently list of I. Okay, so basically I think that's all there is to it, but let's go ahead and run this and see what happens. So if I do up, so now you can see that it is following correctly, right? Beautiful, looks beautiful. It looks beautiful. And why this is just simply, you know, arrangement of elements. For example, I already had this direction, like let's say this was the snake, 3 points. If I do up, then only I am getting the head, okay, and updating this value as here, and I already had saved this value, so I'm just adding that and rearranging all the elements accordingly according to this position, and whatever the last position of this element was, I'm just rearranging them. Okay, so it's actually easy. All you have to do is just try it yourself, so that would make you understand a little bit better, right? That's all there is to it. Okay, so now we have directions are working perfectly fine, right? It looks wonderful. And we also are moving in right directions. Snake points are updating correctly. Now what would be the next logical step? Okay, let's go ahead and first now just play with the design a little bit. I want to so I am using this round rectangle, and round rectangle, like, unless you provide any corner radius, it will act as a normal rectangle, which is a really good thing about them. So but now I can just pass I think corner radius, yes, so, and it pass corner radius. I just want to pass 0.2f. I want to copy, and okay, cool. So this will look, I think, a little bit better. Okay, cool. Yeah, it does, certainly. Now I want to draw this two beady eyes and tongue. Okay, I mean, it's not entirely great, but you will see. Okay, so let's go ahead and first of all, if we want to draw, I will just explain a little bit before. Okay, so this is going to be the head of the snake, and if it's left direction, okay, then we are going to add 2. If it's down direction, then in head of the position, like this is head, I'm just going to do two circles, and like this. Similarly, for all the directions, right? The main important thing to note here is that whatever the square is, its top left location is here, always toward, like, by the side of this origin, top left. So once you remember that becomes incredibly easy, because this is the location that we have available, right? So for example, if we are going towards the right direction, and this is the x and y coordinate available top left, what's the position here, then you can see I need to travel to, like, a little bit around like this, and on y direction I need to go down a little bit and draw another circle, and in the middle of, I just need to draw like this. So we can follow the same step based on the direction, right? So here I will get the position of the head first, so value head would be snake dot first, right? And now I can just say draw snake head. Okay, and I'm just going to pass the head, which is just an offset, right? And I do need direction. Yes, I do need direction, and that I can pass. I just need to pass. What am I doing? So yeah, direction. Okay, cool. and I'm going to make it as an extension property, so we don't need to pass the canvas, right? Cool. So we have offset, which is, let's call it head, and direction is fine. So everything is dependent on the direction. So let's go ahead and direction based on this direction. I want to draw a certain way, right? So okay, cool. Now I want to draw two circles, tiny circles. Okay, so now draw a circle, color is equal to color dot black, because I'm going to use black color. Circle needs radius, of course, so radius I just want to have 2.1 f, because remember one size is now 90 by 90 pixel, so we are dealing with one, and we don't want, if we pass one radius then it will be a really big circle, right? So it's 0.1 is enough. Then what else does it need? So drawing circle requires radius, and certainly this does require center. So where the center going to be? So now we have a head, right? I think center requires offset, right? Indeed, yes. So this is offset, so we can just pass offset head.x. so remember when it's exactly, let's follow this one. Okay, let's follow this drawing. So we are in the left direction, so let's left direction, and this is the snake. Okay, I want to draw true, and so top left of this one, the head offset is here, here, and here, but right now we are only concerning ourselves with this one. Now we need to draw true circles and one line. So as you can see, top left, so which is here, I'm not traveling too much on x direction, and on y direction I'm doing one here and one here, right? So let's just follow this one. Okay, I'm just going to keep this drawing. So x, I'm not traveling too much on that direction, so let's just say 0.2 f. Okay, on an y direction I'm not traveling as much, 2, right? 0.2 f. Okay, now the second circle, I am traveling a little bit towards the end on y here. I hope you're following my cursor here, because so yeah, here. So I can just pass 2.8. okay, and x doesn't change because we lever, right? And now I can just draw a line, right, which would be our tongue, right? Essentially color dot black, and let me just go ahead and clear this drawing now because we don't need it. So line of course requires start would be, we can just say start position would be x plus a little bit towards the right side, right? So head.x plus 0.2 f, but the tongue is in the middle, right? So let's just say head.y plus 0.5 f, right? And we can just say end is offset, so that one will add as head.x minus 0.3 a little bit on the other side, and head.y would remain the same, right? So that is the basic idea here. Okay, and let's go ahead and run this, see what happens. Okay, so we only define this code for you know, left direction. So let's go ahead and left. Okay, so it does work. The problem here is we need to actually have a stroke width 0.1f. Now that would make the tongue a little bit visible, so you can see it now. Okay, yeah. Let's do that. Okay, so yes, we can see that it works. Now we will follow the same logic for all of them. Right, so towards right we are going towards around 0.8. okay, y would be 0.2 and 0.8. that sounds good. Both of them will start at 0.8. this one will be, y would be 0.5, yes, but here x would be 0.8 and here would be plus, I think, 1.3. that should be good. Let's go ahead and run this and check. So left direction, this is the right direction, so it does work. And now let's go to up direction. Let's take a breather. Okay, so up direction. So up direction, we are going to move towards x direction, right? But not as much in y, right? So we can just say 0.2f. In x direction, we are going to move a little bit farther from 0.2 to 0.8, and I think that's all. And when we are drawing a line, we will be in the center of the x coordinate, right? So x 0.5f, and then similarly goes here because it will be a straight line. But in terms of y, we are going to start with 0.2 and we can do plus 1.13. let's go ahead and test this. Okay, it does work. It does work indeed. Okay, cool. Now I can just copy this similarly for down. So for downwards, I am traveling towards down on the y direction, so 0.8 here. X direction would be 0 and 2, that should be fine. In the middle, x stays in the middle, but y here I want to do plus 0.8, and here I want to do plus 1.3. that should do it. Perfect. Okay, so yeah, that looks pretty beautiful. Okay, and that's all about it, about the design. So now now let's move towards the development of placing the food. Okay, so to place the food, I want to have 2 or 3 variables, let's say. So food related. So first of all, I need food location, certainly, right? So variable food location by remember, and it will be mutable state of offset 0f 0f. That's the default I'm going to pass. Remember. So you have food location. Now we can see that how many times we are going through recompositions in this one. The loop is going on and it is going through so many times, like 10 times per second it's updating its position, right? And because of that, and we don't want to keep updating the food location every time, right? So we will want to have a flag that would prevent it, right? So variable update food. initially I want to have it true. Okay, and this is just my my own preference. I just wanted to create a random color every time, so food color, and remember just passing it initially like that. So whenever we say update food, which should go here, let's just say if update food, then I just want to immediately say false, so we don't execute this block. Now I just want to create a random point on the canvas, so I can just say value x and int 1 to when we are dealing with columns, yes, x is columns, right? And here I can just say y. Oh, okay, sorry. Rows. Okay, so now we have this generated location. I can just save it. Food location is equal to set of x default to 4. Okay, so it will be within this available space of the canvas, right? Because we know how many rows and columns will there be, right? And food color, I want to just say get random color, and I would just return that. And in this case I don't want extension property, I mean extension function, sorry, because I don't need that, right? I don't need the reference of the canvas. And to generate that, all the colors are generated using 3 values, RGB, right? So value or red is random.next int from 1 to 256. So RGB, and I can just return B. So now we have this random color. Okay, all we have to do is render that food every time, right? So round rectangle. Okay, color is equal to food color. We define that color, and top left corner is what we need is food location, because we already generate that location, food location. And I think we need size 1f, right? Otherwise it will be really big. I think that's about it. Let's go ahead and run this. Okay, so it generates. Okay, it doesn't get consumed, but we will do it. But for now it generates random location, right? And where is it right now? It is visible, yeah. So color was a little bit, so okay, so now this time is a little bit darker, so I can see on the screen. Okay, cool. So every time at random location we can call this food, right? Food for the snake. Now I want it to have a little bit round, I guess. I can, it's up to me, you know. Corner radius would be 0.2f, no, 1f, so that's good. Okay, cool. Now in demo I showed you that it was rotating, right? So we can certainly do that, and to do that we need rotate transformation function, right? So let's use that. So just like scale, rotate is another canvas transformation function, so we can use that. Rotate, yes. What parameters it needs is degrees. Degrees. So for now let's just say 12 degrees. Okay, pivot point, and what does it need? Okay, and then it's just a lambda function. Okay, so pivot point would be, so pivot point we can decide it like this. For example, this is the food. I can just draw. So this is the location here, right? We want to rotate this square, so we need to have a center point, like this is the pivot point. So we can just say x plus 0.5, because that's going to be the half of the square, and y going to be, so this will generate the center point. So let's just go ahead and do that. Offset food location dot x plus 0.5 f, and food location dot I think so that's all. Why is it complaining? Okay, yeah, because we need to do that. Okay, cool. Okay, you can just format this, and this would not rotate, by the way, because we have a static, you know, variable. We need some sort of a variable that will keep changing here. Every recomposition it will change, right? And that's exactly what we can do using remember infinite transition. So that's the animation that we are going to use. Variable infinite, it's value infinite transition is equal to remember infinite transition. Okay, now the value that we are changing is the angle, right? Degrees, and degrees are so I can just say value angle by infinite transition dot animation float, and in initial value I am going to pass 1f. I can pass 0f. Target value is 360, so that will perform the full rotation, and I need animation spec infinite transition. Let's call infinite repeat. I really can't remember this one. I really need to look at it. So I'm just going to look. So what is it called, by the way? So yeah, infinite repeatable. Sorry, infinite repeatable. And in here I can pass a repeat mode dot, I want to just restart it, I don't want to reverse it, and animation is equal to tween animation. How many duration? So every, let's just say 1 second it want to perform, and easing would be linear easing. So now every 1 second this angle value will go through 0 to 360, 0 to 360 again and again. Okay, and that's what we can use here as angle. Okay, and now every time that angle variable updates, this rectangle will rotate from this pivot point. Okay, so let's go ahead and test this. And there it is. So it rotates, looking lovely. Okay, now we need to actually, handle the logic to consume the food. Okay. So let's go ahead and do that. How do we do that? So that's incredibly easy, right? So if I can just explain it. So I have this one point. If snake is at here and this snake goes here, so this location we have food location and this one is the head location, right? If they both are equal, then we can consume the food, right? So that's super easy, right? So we have head during a live state. If head is equal to food location, then things will happen. What things will happen? So we want to show the score, update the score. We want to extend the snake. And what else do we need to do here? And we need to actually reset the food location, right? So resetting food location is really simple, easy. Food location dot true. So update food. Now it will re-execute this and generate a new point. So that's easy. Score is something that I can need a variable to handle the score by remember mutable state of, I would say mutable int state of, and initially 0. Okay, just a minute. So initial value was 0. Now here I think we need to, so remember is used to preserve the state of this composable function. That's its function, right? Let's go ahead and check the documentation. So remember this, the value produced by calculation will only be evaluated during composition. Recomposition will always return the value produced by exactly. So what I said is like preservation of state or values through recompositions. Composable functions, they are functions, right? They are not like, fundamentally they are functions, and whenever you call function and that execution gets finished, the values get reset, right, in normal function. But this is a composable function, and this will go through recomposition, and we don't want to lose those values, right? And that's what this remember does. This will help us to preserve, even after the execution of that composable function, it will preserve the state, right? But here score, so we are using remember a lot, right, to preserve the state, which is fine. But score is something that we don't want to lose even when we rotate the screen. When we rotate the screen, configuration change happens and every value will get reset, right? Other values get reset, we are fine with it, but we don't want to have this score get reset every time like rotation of the screen happens, right? So in here we want to use rememberSaveable. rememberSaveable will allow us to keep the value, preserve this value even through the configuration changes. So that's why I'm using rememberSaveable. And in text view, instead of showing width and height, now I can just show the score. Okay, score just like that. While I'm at it, I just want to type that one to tap to start the game, and I also want to say double tap to restart the game. That those functionality or like feature, whatever you want to call it, we will code it as we go. Okay, but right now this is going to show the score. So let's update the score, and when this happens I want to have update the score. So now we are updating, and this is a new method that we need to create, ViewModel.extend snake, and that I can just create it using this. And here snake manager will handle that responsibility. So this should be incredibly easier. So value, I want to copy that first. Okay, I copied it. Now what I want to do is get the last, let's say tail list.last. Okay, and I want to do immutable state because I want to change it, right? I want to add element. So now I have that tail. I can just say tail.x plus 1, tail.y plus 1. We are just adding one element, we are changing it, and I can just add the newly updated tail, and I can just say this snake is newly developed list. This should do it about the extension of the snake, right? So let's go ahead and run this and see what happens. So currently, okay, the food is not visible. Okay, cool. I can just go ahead. Okay, so we are updating the score now, and it's consuming the food. Now if we rotate the screen, the configuration change survived, right? And that's what we want. So score survived because we are using rememberSaveable, so that's perfect too. So you know, everything is coming together. Now the only remaining thing is that we added this tap to start the game and double tap to restart the game. So that's what we can handle it now. But before that, I want to actually handle this dead state. So right now the snake can you know, snake will, I have to actually use the touch screen. Yes, so snake can pass through its own body. I want to prevent that. I mean, we want to detect when snake head touches its own body. We want to make use of this dead state and restart the game, right? So to do that, I will do calculate. So value counter is equal to snake.count. So count and head is equal to, okay, so this is a really helpful function. So returns the number of elements matching the given predicate. So this is the predicate that we provided, right? I'm saying how many times head exists in this count. If it exists more than one, because the snake entirety, it will have at least one head, which is fine. But if the same point is also available in other, like more than one, counter greater than 1. So if I can explain this way. So if this is this snake, and if the head is here, so what will happen here is head's position is 1 time and other snake body segment is 2. So whenever this position, head position, is more than once, then we can safely assume that it touched its own body, right? So, and then we want to change the state like that it's dead, right? So snake ViewModel update snake state, and I can just pass snake state dot dead, and I'm just going to pass the current snake that we have available. When it's dead, what I want to do, so is that all we need to do? First of all, I need to actually, let's go ahead and run this and see what happens. Okay, and for the sake of testing faster, because I don't want to play and extend the snake, so I can just say generate random points, 10 random points and start. Okay, now let's go ahead and do this. Okay, so it disappears because in this state, when it switches to dead state, we are not doing anything, but we still want to show the snake, right? We don't want to just, so we can just say draw snake and state.snake is available there, right? So we can just pass that, right? Now I want to create this animation, right? So whenever it touches its own body, I want to keep it flashing, right? So this is the same way, but instead of manipulating value of angle, I'm going to manipulate like go back and forth, oscillate the value of alpha value. Okay, and this one will be faster, and alpha value goes from 0 to 1, right? 1f. Okay, so let's go ahead and make use of that alpha value that we have now. So while drawing the snake, we are not passing the alpha value, so now we can pass alpha value. We need to just change the signature of this alpha float, and I'm just going to pass a default value. So while it's alive, we don't want to mess up anything. When it's dead, we are going to pass the value, so we don't have to unnecessarily pass alpha unless we are changing it. So alpha, I can just say copy alpha. Okay, there is to it. Let's go ahead and test this, see what happens. So whenever it touches its own body, we want to have that animation, right? Okay. So it's blinking, right? So we want to, instead of restart, we can just say reverse. Okay, so it goes from 0 to 1 and 1 to 0, so it won't be a little bit jarring, right? Right now it's jarring a little bit. Okay, cool. Okay, so now it looks smooth and nice. Okay, so whenever it's doing that, we are not actually showing the eyes and snake too, right? So we can do that using draw snake head. We can just pass snake state. I want to have it here, snake state.snake, and in here I can just pass. I can just pass this snake dot all the snakes we need, and while drawing the head, we just need first position. Okay, and we need to pass direction, by the way. Yes, so let's just do snake for get direction. I want to, create that method, and this will just return us, hopefully I can just do direction, right? Oh, I need to return it, sorry. Okay, cool. Let's see how it looks. Yeah, so you can see beady eyes and two, so that's perfectly nice and Yamaguchi. Okay, cool. Now what is remaining? So we want to reset the state, right? Because this will keep blinking. How will we actually, you know, so after 10 seconds I want to reset to initialize. So I can just say here, and that's I want to delay it. For the sake of testing, I will just keep 5000 for now, but ideally I want to do it 10 seconds. And then after that I want to update snake state, and I want to pass it snake state, not init. Okay, and it's important to break out of that loop, right? And when we break out of this loop, it will just initialize it. Let's go ahead and try. And 1 2 3 4 5. Okay. Makes sense. So here we are. So what happened here is it went to deaths. After this, it set to initialize, right? Initialize state. In snake screen, it fall through here, and initialization snake, we generated random point again. We started keep tracking of that, keep like by turning that state alive. So it fell through now here. So that's why I drawn this snake, and then we started loop again. So that's what happened here, and we don't want to call this here because we want to have this ability by ourselves. Like whenever user taps on the screen, we want to start this game loop or this coroutine that would keep track of it, right? So for that I will just say pointer input, just going to pass unit. I can just say detect tap gestures, and here on double tap, on tap, let's say, and on double tap, I want to do something. So on double tap I want to restart, on tap, yes, I want to start. So here I can just say ViewModel dot moveSnake. So let's go ahead and do that now. Now let's see what happens. Okay, so I'm not even showing, I'm sorry. So here it start the snake. Let me make it dead. So after 5 seconds, so on tap, now I will be able to start the snake, right? So now I can start the snake. Now that's wonderful. On double tap I want to reinitialize, right? So I can do that snake ViewModel using init snake, right? That's not a problem now. So let's see, go ahead and do that. If I do restart, I do that. If I do double tap again, it restarts, initializes new position and keeps the state alive. I hope you guys can see it. If it's dead, then after 5 seconds it will reset its position, and now using tab we can start. Now the problem here is, and it's a huge problem, so what if user taps twice? If that's the case, then this moveSnake will get triggered again, and it will relaunch, like it will launch another coroutine, right? And it will have another infinite loop, and keeps updating that state. So let's tap again. So you can see snake is going really fast. Every time I tap, if I tap 4 times, then there are 4 infinite loops running, right? So we don't want that. We want to prevent that from happening. So first of all, I want to create a flag. So variable, and I'm going to say just start game and remember and mutable state of true. Okay, so I want to use this variable to first of all prevent that. Okay, unnecessary call start game, and start game would be false after that. So only one time this will be executed. Okay, so that's how I am trying to solve that problem. Let's see. Now if I tap, nothing is happening. If I do double tap, it actually is keep running. But I want to stop the snake when I'm actually when I'm actually double tapping. But one interesting scenario here is that, let's say this one is going on 10 seconds, but I just want to double tap, instantly it resets, but see again it reset the position. Now that's the problem here. So what if I have 10 seconds here? Let's keep 5 seconds because I think it's, for the illustration purpose, it's normal. So keep an eye on this. So this will reset, but I've pressed double tap, so reinitialized alive, but after 5 seconds it reset position again. And here what it happens is it delays and it waits, and then it breaks out of the loop, right? And this coroutine is not destroyed. And what we need to do here is to cancel this coroutine if that's the case. If we actually double tap, we don't want to even wait for that delay. We want to immediately cancel that delay. And that's something we can do using a job. So job itself has so many features, but for our use case, we can just simply understand that job is like a remote controller of a coroutine. Using job, you can investigate whether this coroutine is running or not, make other coroutines wait for certain coroutines to finish. So job does a lot of things, and one other thing that it does is allows us to cancel all the coroutines. And this is exactly what we need here, right? So we can just create a job that is of type job, and I'm just going to pass null. Okay, and every time I go, I want to actually, because this loop I don't want to have it more than one time, and it's unnecessary, and it's going to waste resources. I don't want to launch this moveSnake method and cause it to restart this infinite loop again, like more than once. So this will ensure that, and I need to take the reference of that coroutine in that job by doing that. Why is it complaining? Oh, it just needs variable. Okay, sorry. Okay, so yes, we need that job. Now I can just create a one helper method. It's like function stop snake, and this would actually cancel it. So we would have the ability to cancel that coroutine in case that happens, right? So in double tap, I want to actually say snake ViewModel dot stop snake 2. So when it says stop, let's see what happens here. Okay, So if I do this, if I'm doing like this, if I do double tap, now nothing will happen because that coroutine got cancelled, right? So if I do double tap, let me restart. Okay, yeah, so right now I'm tapping, but it's not responding to my tap because, you know, whenever we stop the snake, we want to be able to start the snake as well, and we currently are using this flag, right? So we want to say start game dot true. Now allow for it to start, right? So let's go ahead and test it. So it go ahead, and this is the dead state. I will double tap to restart the game. Now I can tap and the snake can move its position, correct? So now it's working as intended. Now if I do double tap, it stops the coroutine from running, and now we can tap and go. Okay, so the one other thing that you notice, if I do double tap, right now the score is not reset, so we want to reset that score too. So we can here say score is equal to 0. So this will ensure that score is reset, and every time we want to make sure that initialization stage hit, we want to also score is 0, and we want to also allow the start game to true. This will ensure that we can do that. Okay, so now after 5 seconds, but if I don't wait, then it won't reset the position because it immediately after double tap cancel this coroutine. Okay, but if I want to wait, then I can just wait 1 2 3 4 5, and it will automatically do it. Now I can just tap and restart the game. The score is also reset. So let's go ahead 1. Now if I do double tap, score is reset. Okay, everything is great. I think everything is coming together, and we are coming to an end of this video session. One more thing, I think, other than that, is there anything I need to do? Let me just check my points, right? Double tap, we are handling all of that. Okay, so the last step I want to achieve here is to have the life cycle awareness. Okay, so if this loop is going, if I do if I put this app in the background, then what happens is it's still running, right? It's still running, and it consumed the food too, by the way, and that's not something I want. I want to actually pause when this case happens, because if the snake length is so big, it will actually, you know, cause it to game over, right? If we put into background. So that's something I want to do, and we can do it using Lifecycle Observer. So let's go ahead and let's say lifecycle owner. We need first of all owner, lifecycle owner, and that reference we can get using local lifecycle owner.current. Okay, now that we have lifecycle owner, we can use DisposableEffect. So DisposableEffect, instead of I explain, let's just say documentation, because this one has explained really well. Okay, so side effect, the completion that must run for any new unique value. So I am passing here lifecycle owner as a key. So it just means that whenever this key changes, this lambda block will execute. Okay, and Disposable key is a value that defines identity dispose. If the key value changes, must dispose. So yes, so the key where you should use this, in a way this is exactly like a launch effect, but disposable allows you to have this helper method called dispose on dispose. This allow you to perform some cleanup, right? So if you register some listeners, you must actually listener or observer, you must remove that observer, otherwise it can cause memory leaks, right? So these are the examples of key include observable objects and unique request parameters that must cancel or retry if the parameter changes. So this is the use case here, and our use case is whenever a lifecycle event changes, I want to execute this, right? I want to keep track of lifecycle events, and if lifecycle owner changes, which means if this is destroyed or created again, then lifecycle owner will change, right? So we want to do a cleanup a little bit, so that's why this on dispose is available. And now let's go ahead and grab the events. So lifecycle events, so this is going to be events and lifecycle event observer. Okay, in event observer, what do I get? So I get lifecycle owner and events, which I'm interested in. So if events is equal to lifecycle on pause, then I want to ViewModel pause this snake. ViewModel dot stop this snake. Okay, and when I'm stopping, actually I have to allow user to start the game. So because we are using that flag, right? And now let's just add this observable to lifecycle owner. So lifecycle owner dot lifecycle dot add observer lifecycle events, and on dispose, if it were to change this lifecycle owner, then we want to just remove it, right? Remove observe. Okay, cool. And that's about it. Let's see. So if it's going, if I do in the background and if I run it again, so it's exactly paused. Now I can just tap again and continue playing the game again, and that is the intended effect, right? So if I do like this and if I do background, it should not consume the food, and it stayed exactly there. So using this way we can keep track of the lifecycle events and take actions depending on whatever the app goes through certain lifecycle events, right? So let's go ahead and try this game, and I think that is all that I want to do in this game, right? So it will game over, and certainly. So yeah, this marks the end of this video. I have done everything that I wanted to achieve in this game and showcased everything. So with that being said, thank you very much for watching. I really appreciate it, and I hope you learned something new. If you have any suggestions or improvements or even thought on this video, what do you think about it? Please comment down. I will add the link of this project in the description down below. And that is all. Thank you very much for watching, and see you in the next one. Okay, thank you very much.